this is the theorem. They abbreviate it with HL, and it's saying if the hypotenuse of each triangle is the same, and you also have a leg, so it could be this one is the same as that one, or it could be this one is the same as that one, then turns out that's enough to know that all the parts of the triangle are going to be equal, all the sides and all the angles.
Okay, I get what you mean. But what if like they're like connected? If that makes any sense. Like they intersect with each other. Could they still be HL or no?
It could be, yeah, because you might actually have
Because I
some
had a
sort.
problem in my previous test. It was like they basically like intersect, looked like this, and there's like a line.
Would it have been like this?
No, it was two, and they were like they looked like this.
Mm-hmm.
Can I annotate it or no?
Yeah, you can.
How do I do that? Oh, okay.
So at the top, it should say viewing Matthew Sullivan's screen.
Oh, annotate. Okay, yeah. It looked like this. Um, something like that.
Okay, are you trying to draw something more like this?
Yep.
Okay. Yep. So you would still be able to use that as, in fact, one of the easy things about this example is that they share this leg. And when you share a side between two triangles, we usually put an X through it. Have you seen that before?
No, I've only seen the congruent like dashes.
Oh, okay. Yeah. Well, this is basically congruent because you could say that this side is congruent to itself. But
Oh, that's reflexive property, right?
I'm sorry?
That's the reflexive property, right?
Yes. Yes, that's right. If I wanted to, I could just put a single mark here and say that they both have that. But usually we just put a X on it. And yep, then as long as this hypotenuse was equal to this hypotenuse, then you would have HL ready to go.
Okay, so hopefully I did that right.
Do you want to show me the problem that you did?
It was on a test and they won't let me review it right now. So, but I remember being something like that, and maybe I think the hypotenuses were congruent. So yeah, I probably was HL.
Oh, okay. Did you get like a homework example that was similar to it?
I'm gonna go try to find one. Because my homework's very mixed matched, if that makes any sense. Like he just gives random problems and you just have to like give them the answer.
Mm-hmm.
So here, give me 1 minute. I'm gonna try to look for it.
Okay, cool.
No, so my biggest trouble is proofs, if that makes any sense. Like I just have trouble with like thinking about something to like explain it.
Right, right.
And like thinking like going backwards. Like I just don't think like that. I think very algebraically and it's hard for me. So I kind of
So,
just want to like I kind of just want to like understand proofs before like I understand anything else.
okay. Do you want to run through an example over here?
Yeah.
Okay. Okay, so they're giving us some sort of diagram,
Mm-hmm.
and they're also telling us that AB is perpendicular to BD. Well, here's AB, BD is there, so that means you have a right angle there.
Mm-hmm.
And they're also telling you that AB is parallel to DC. That means that this one and that one are parallel. And they're also saying that AD is congruent to BC. Well, AD, that's going to be a hypotenuse.
Yeah.
And BC, that's also a hypotenuse. So those ones are congruent. So in order to mark that up, I could just say that this thing going across is equal to the other one going across.
Isn't there midpoint at all or no?
Is the midpoint gonna bisect it? Is that what you mean?
Yeah.
Not sure. I'm not even sure if we're gonna need that info. But
Oh,
let's see what they're trying to get us to prove. They're trying to get us to prove that DAB, which is over here, is the same thing as BCD. And BCD, that would be up here. Okay, so in order to prove those, let me just make sure we got the right one. DAB and BCD. All right.
well, you have to start with, don't you have to always start with given or no?
Yeah. So they did give us all these givens, so I could just copy these. But yep, you're right.
That's like the only thing I know. I use postulates and theorems and definitions. That's literally all I know about proofs. But
Okay.
I do know for like you had to like prove the triangle's existence, and then you had to prove by like A, S, A, or something like all that stuff, and then you had to like say C, P, C, T, C.
Right. And in fact, in this one, they're even giving us a hint. They're saying we can show that these two triangles are congruent. So if I want to focus on those for a second, ADB, well, that's this triangle between those 3 points. And then CBD, that is the triangle that is very similar looking, but between those 3 points. Are you able to see both of those?
Yes.
Okay. So let's see. What did they give us? They gave us the hypotenuses of each of them. Now, technically, we don't really know its hypotenuse for the orange one yet, though,
Yeah.
because we've only got a right angle down here at B, but we didn't really get a right angle up at D.
But
But
it's obvious, right?
well, yeah, obvious is not something that we're allowed to say in proofs. So how would we say it?
Um, it's a right angle, right triangle.
Yes, you're getting there. We want to say that it's a right angle. How do we know it's going to be a right angle?
Oh, okay. There's like a rule or something with that. 90 degrees, right?
Yes. Yep. Yeah, we definitely want to know that it's a right angle, but you don't really need to say anything about 90 degrees here. It turns out it's the parallel that's going to help you. Because if you have parallel lines, that means that you can also draw in a transversal. You might be wondering, okay, well, where am I putting my transversal? You want to put it so that way you're going to get your right angle to be touching the transversal. Just means the line that goes through the parallel lines.
Yeah. So it's the perpendicular rule. It's like if one perpendicular, like if the two parallel lines, one transversal hits the perpendicular, the other one's gonna be perpendicular too, right?
So that would be a theorem. Have you already seen that in your course so far?
Yes.
Oh, okay.
Or
Well,
or
then,
same, or same side interior equal like or supplementary, right?
yes, exactly. But the way you said it is going to be a little easier to write down in the proof. So we are going to kind of need that. So let's get started. Let's say that angle CDB is a right angle. And then the reason that we're going to give, any idea what we're going to type out?
I just said it, right?
You did.
It's like the theorem. I don't, it basically, if two parallel lines are cut by a transversal, right? It starts with that. So it's two parallel lines, they're cut by a transversal, and one of them is perpendicular. The other one will also be perpendicular. It's something along the lines of that. I don't know the exact wording, but I do know it has something to do with that.
Yeah, you're right. So if two lines are cut by a transversal and the well, actually if two lines are cut by a transversal that is perpendicular to one line, then it is also perpendicular to the other line. Now, what that would get us though is that CDB
Is a right angle.
well, not immediately. It would get us not CDB is a right angle. It would tell us that
CDB is
CD
supplementary.
is perpendicular
Oh,
to BD.
okay.
So then once you put that, you would be able to say that CDB is
A right angle.
right. And why do we know it's a right angle?
Oh, because this is the second thing I said, like the same side interior thing, or no? Oh,
No.
because it's perpendicular. Because
Yes, exactly. So what you can say for that is
definitely.
definition of perpendicular.
Yeah. Okay.
And I don't know what kind of strictness your teacher is going to be, but
No,
whatever
no.
you can.
Yeah. He allows that. He likes definitions.
Okay, cool. All right, so we finally figured out that CDB is a right angle. Okay, so now it's probably useful to restate, even though we have it in the givens, let's just restate that AD being equal to BC is the hypotenuses of each of those triangles. Now, instead of restating it, what we could do is just mark it up. And this is really just for us, just to recognize that these are the hypotenuses. So as long as you have a statement that says that the hypotenuses are equal, you're well on your way to using hypotenuse leg. So we still want to be able to say that the legs are equal. Well, do we have a way of showing that two legs are equal from those two triangles?
HL, right?
Yeah, but we need to say which leg from the first triangle is equal to which leg from the other triangle. So a lot of colors going on here. Let me make it a little bit simpler here and just highlight only the triangles we're interested in. So we're interested in this triangle and also this triangle. So between those two, do we have a leg that we know is going to be equal to the leg from the other triangle?
The parallel lines. So I know it's the parallel lines, right? No, I know. No, it's not because that's the hypotenuse, right? So okay, so that's not going to be it, is it? The reflexive property, right? The same side one, the reflexive property. So
Yeah, there you go.
dV is congruent to dV. Okay, that makes sense
Yeah,
actually.
we can mark it up just with an X.
Hmm.
But yep, what should I write for the reason then?
Um, reflexive property.
Excellent.
It takes me a while to think about it because I'm not used to like doing geometry. So
Well, you might find this weird, but you're off to a excellent first start. So a lot of students they find the most fundamental steps of this challenging to logic their way through, but you're doing great.
cool.
Okay. Anyway, so we already said that we had our pair of sides that were equal, that were both hypotenuses, but now we've got our pair of sides that are equal, even though it's itself, that are legs. So we now have our H and our L. Therefore, we're going to be able to use that as just the reason for the statement of what? What's our
The
statement?
tri the triangles are congruent.
Yes, exactly. Okay, so we're just going to say that this triangle is congruent to that triangle. And then the reason is just HL. But did they want me to stop there? What did they want me to do?
What's it called? It's the CPCTC thing because you have to still prove the angles are congruent because corresponding parts are make congruent triangles, right?
You got it.
Mhm.
You just
See, that
described
part,
statement 6 and reason 6.
it's the first part that confuses me more than the second part. So it's like figuring out how like which one to use and stuff. That's what confuses me. But like once like I got like ASA or HL or something, then it's easy from there because you only have like one or two more things to do.
Okay. So let's just recap the steps. Once you write down your givens, can you explain what we did in part 2?
You stated you basically said that they were segment CD and segment BD are perpendicular because of the theorem. Is it a postulate or is that a theorem?
That should be a theorem where the postulate would be different. But yeah, that
Okay.
should be a theorem.
Yeah, so basically because of that theorem. And then the second one saying that like it's a right angle because like that's perpendicular lines are right angles. And
Yeah, it's just
then
the definition of what perpendicular means, right?
yeah, then you have to show a leg because you already have the H, you need the L. And then once you proved each of those, then you could like prove the triangles. Okay, it makes a lot more sense.
Awesome. Good recap.
Do you have any more examples?
Let's take a look. And by the way, I'm gonna be sending you these notes here. So this is gonna be emailed to you at the end.
Okay. Okay, cool, cool.
Oh, by the way, they did have their way that they wrote it out. If a line is perpendicular to one of two parallel lines, is perpendicular to the other. That's basically the same reasoning, same wording rather.
Hmm. Okay, it looks basically the same. They went like a little bit off, but that's about it.
Hmm.
Sometimes the people that make this stuff just like go way into detail that like we don't need. Like they just say too much. Oh no. Okay, this one looks scary, but I want to do it.
Number 16.
Yeah, but it looks scary.
Well, if you think this looks scary, wait till the course makes it to circles, and then we
No,
have
no.
triangles inside of circles.
No thanks.
Well, you're getting there. It's gonna be the second half of the course.
Fun, fun, fun. My mom said that the second course is easier, the second semester. Mm.
I mean, I guess it is if you've mastered the first. If you've mastered the first, you already get the basic idea. You're more comfortable with how to do proofs.
I'm like, I'm like I wouldn't do them, but if I had to, like I'd try, but I don't know if I get it right.
All
Like,
right. Well, I believe in you. Let's give this one a shot.
okay, so those are rays because it's angle. I know that.
I'm just gonna mark up where the right angles are, even though we're gonna have to write it down. But PB ABC. Okay.
Wait, is that? Okay, hold on, hold on, hold on. My teacher told me that when you're like doing notations for rays, there can only be two letters, not three. I don't know.
Well,
So wouldn't that be ray like AC?
you could just call it Ray AC if you wanted to.
Okay, yeah. He marked off a kid for that before, so I'm just gonna go with ray AC.
All
It's
right.
fine
Well,
though.
if the guy that wrote this textbook took a test with your teacher, then he would not get 100. All right. So we got those right angles coming from there. And then PB and PD. I'm just going to put a single mark for each of those. Okay, so statement number one. There it is. Be nice if you could do that, right?
Yeah.
Well,
Because I don't have these on my test, I just have them on the final. I know that.
wait, you mean proofs are not going to be on the regular test?
No, they weren't. They're all multiple choice.
Oh,
But
okay.
but they did ask in the last test, like, oh, which one is it? ASA, SSS, stuff like that.
I
You didn't
see.
have to, yeah. But the final will have like it's free response on proofs.
Okay. Well,
But I
how
still
have you
want
been doing on like the non-proof problems so far? Have you been getting most of them right?
50-50. But proofs is the part I struggle the most on, like on the homework especially.
Okay. Well, maybe after this one, do you want to show me some of the multiple choice that you didn't know?
Yeah,
Okay, let's do that.
like from like my older tests. Yeah. Okay.
All right. Okay, so we got the given. What do you think is coming up next?
Well, I need to process this. Hold on. Okay.
Sure.
Yeah, ABC. Okay. And then with PB, particular ABC. What's that? P is perpendicular. Oh, okay. Okay, yeah, okay, I get it now. It was a bit confusing at first, but I got it. Okay. So you want to prove that APS bisects CAC. Okay. Um, so wouldn't you have to prove that they are triangles first, congruent triangles,
Yes.
and then you have to prove why they are congruent triangles. So they share the same side because that's a bisector. Um, so it would be,
Are you saying that they share this side?
yeah.
Okay, yep.
Yeah.
So we'll definitely get that down. That AP is congruent to itself.
Okay, it's reflexive. Um, okay, so that's a side. Is there what are the ones again? Here, let me check which ones there are. I want to see like the 5 ways. I want to make sure I'm not like messing this up in my head. Uh hold on for 1 second. Yes, okay. Um okay. Oh, you wrote them down. Thank you.
Yeah. So
Um,
there's actually a little bit more. You
there's two
could
more. Yeah.
then also put in AAS, the one that's particularly humorous. That one doesn't work. So it's kind of convenient that it's the only funny one because it's easy to remember that that's the only one that doesn't work. Uh, but technically, it kind of does work if you think about it. If your angle is a right angle,
I mean,
if
it
your
has to.
angle is a right angle, you kind of do have something slightly humorous.
Hmm.
In other words, you have hypotenuse leg, but that's why it's called hypotenuse leg and not something else. Anyway, so it only
Okay.
works if you have a right angle.
I was
But
about to say hypotenuse leg because so they share this that shows the hypotenuse, so they share that, and then the legs are congruent. So it's given that one. Wait, no, it is. But yeah, it is given. Or you could just write segment PB is congruent to segment PD, right?
yeah, we could, but there's already so much writing that
Yeah.
just like in the last problem, I had decided to just mark it up. Then as long as you just mark it up like that, then you've already got what you need, which
And then you
means
triangle A P, ABP. Would that work or not?
ABP, yep, is congruent
And then
to
AGP, right?
yes. Yep, as
Okay.
long as you're consistent, as long as all the points match up. And then the reason?
Um, HL.
Good.
Okay, so now, okay, we don't really need the. Mm, okay, this is where I struggle. Any clue?
Sure. Well, work backwards. How would you prove that some sort of ray bisects a angle? What does it mean if something bisects an angle?
It splits it into two.
Yes. So in this case, it would mean that this piece would equal that piece.
Mm-hmm.
Hmm.
Oh, wait, does that count? Does that count as CPCTC or no?
You would be able to use CPCTC to say that angle 1 and angle 2 are congruent. Does he allow you to do that, by the way? Just mark up?
Yeah, yeah.
Okay. So we could say that those angles are congruent. And then what would that mean?
Um, no idea.
It would mean
Oh,
that that line does bisect it. Why?
because it's the definition of a bisector.
Exactly. It fits the definition that your bigger angle gets split into those two equal angles. So if you have those two equal angles, that's it. That means that AP is a bisector. And just to make your teacher happy, I will get rid of this S.
Fun, thank you.
You're welcome.
Yeah, he gets really mad, so
What exactly is the format? How is he teaching you?
he uses the first ones would be A, and then there whatever comes next. But
But like, is he
he
teaching
just
you over Zoom?
okay. He teaches us from videos, so we have a chapter a night, which takes about 5 to 6 hours, maybe seven. And then we just go in person on Tuesday, Wednesdays, and Thursdays for an hour for Q&A. But he only talks like with that one kid that has like the dumbest questions ever.
Wait a second, is that kid like at the bottom of the class or at the top of the class?
the top. But like he asks like very oddly specific questions, like and he butters up the teacher, and no one else can like talk.
Oh, okay. Just constantly asking about details of proofs, right?
He just talks about other things too, and like goes farther than we need to go. So basically, like we don't like everyone else doesn't like get to like ask him any questions, and we don't like he's like, oh, I'll figure it out. So basically, we have to teach ourselves, if that makes any sense. So this is why I'm here.
That does make sense. In fact, I guess I was kind of that kid during the last math class I ever took in college.
I was that kid in biology honors. I was actually mixed between both. I was like that dumb kid, and then I always asked like went too far and asked like the most like oddly specific questions about like genes and chromosomes and stuff. Like I went way too far with that stuff because I wanted to make sure I understood it so well to the point where like I knew I'm not gonna fail because bio honors is the hardest thing I've ever been through.
Well, hey, maybe you're gonna go into biological research or something.
No, I hate it. I hate it. I hate it. I'm excited for chem. I'll just say that, not history. History is gonna be horrible.
Well, I'll be interested to find out how it turns out. Did you want to show me some of those problems from the homework?
See, like he's weird with it. Okay. Actually, yeah, there is a proof that makes zero sense to me because like it intersects a plane.
Well, did you want to show me some of the problems from your latest test that you got wrong?
Oh, yes, yes, yes.
Yeah, I
Forgot
should have
about that.
said that.
Okay, I totally forgot about that. Let me do that.
All right, well, you find those. I'm just gonna run to the bathroom.
Okay,
All right, back with you.
okay, cool. Uh, okay. Do you want me to share my screen?
Yeah, please.
Okay. So it only let me go to chapter 1 and chapter 2, by the way. So it wouldn't let me do chapter 4 and chapter 3. I don't know why, but here's chapter 2. So I didn't do this bad, I didn't do that bad on this test. So here's the ones I got wrong. So I got this one wrong.
Okay, I got number 2.
So fees between A and C, then which is not true.
Oh, do you want to
Yes.
just show me the other ones first, and I'll just take pics, and then we'll do it from my screen?
Yeah.
Okay.
Here's 5.
Got it.
And here's 10.
Okay, got it.
17.
Got it. Okay.
And that's for all for chapter 2. I can show you chapter 1 after if you want.
Okay, why do you think it's not showing chapter 3 and 4?
It takes a while to load. Sometimes it doesn't like it's by week, so maybe by next week it'll like give me all the results.
Oh, okay.
Okay. Okay, you do we'll do chapter 2 first. It's fine.
All right, so you just want to be able to draw this out. They said that B is between A and C, so put A and C on one side, and then put B somewhere between them.
Oh, I get. Oh, it's just a trick question. Okay, because it doesn't have to be in the middle.
Right. So what's the answer then?
No conclusion, right?
One of these actually could work.
So it's not okay. So, well, the first one's the segment addition postulate, but oh yeah, okay, yeah, it's the first one.
There you go.
Okay, So that was dumb of me. Okay. So yeah, okay, I get it now. See, he writes really tricky questions. I gotta like read it carefully.
Well, you're doing just fine. I wouldn't.
Yes. Have a C in the class. It's awesome.
Well, I meant doing just fine during this session right now. So I
Okay.
don't think you're gonna struggle too much if we can clean up all these little questions you got.
Okay. So if A, B. Okay, yeah. This one I need help with for sure.
Okay. Is this picture matching with the info they gave?
Well, apparently it's so, and I got it wrong.
But there's no A.
Mm-hmm.
There's no point B. There's nothing.
Mm-hmm.
And this is for angles, whereas this is for sides.
Mm-hmm.
I think this is a mistake.
So do you think I should tell him to I
Cough up the
mean,
points.
yeah. You know what? Actually, here, I'm gonna take a
That's what I
screenshot.
would do.
Hold on. Was that number five? That doesn't make any sense. So the correct answer is transitive. I can't say that word. Transitive and substitution. So that's
Okay,
the
so
correct answer.
I think we might be able to do the problem if we ignore the picture. So if I were to just cover this picture up, we pretend that that wasn't there, then yeah, maybe we can make sense of it. Okay, so let's see. It tells us that this is true. Tells us that AB plus CD is equal to RS. Oh, okay. Well, then let me just put the RS here for now. And it's also telling me that EF plus GH is equal to TV. Huh. Okay, so what did I do to arrive at this from the first line?
So I thought it was transitive, but apparently I was wrong.
Yeah, the correct answer is supposed to be substitution, right?
No, it's both.
Oh, okay. Uh, so yeah, so substitution definitely works. Let me try to make sense of the transitive one.
Because he did tell me in class that they're interchangeable. I don't know why, but that's what he told me.
Yeah, hold on one second. I'll try to make sense of it.
Whatever. He's crazy.
Well, hold on one second. Right, so the way that I normally think about transitive is if A is equal to B, and also that C is equal to B, then A is equal to C. And the reason why is because you got two things that are both equal to B. So the
Mm-hmm.
A and the C, they're both equal to B, so therefore they're equal to each other. That's basically transitive.
Mm-hmm.
Now, in some sense, transitive and substitution are super similar, right? Because I could have thought about this a different way. Instead of getting to A equals C this way, well, I could have just said, well, if B is equal to C, then I could just substitute this B with a C and I would get A equals C that way. So in that
Mm-hmm.
sense, they're kind of the same, but I'm struggling to see how I would be able to use this same logic. Oh, they're both equal to the same thing, so therefore they're equal to each other. Because ultimately, you would want to think about this as like the A and the C, but then RS, it's here, TV, it's there. They're not exactly equal to the same thing. They kind of are. But maybe what he meant when he said both is that you would have to use both of them, even though you could get away with only using substitution.
Mm-hmm.
So I'm not sure if he meant you would have to use both of them, or it could be B or C.
Mm-hmm.
Because you don't actually need to use both of them. So if you would have selected substitution, then he, I would say, should have still marked you right. I think it's a little unclear what he meant. Let's just move on to the next one.
So he actually explained this one, and from my understanding, from what he explained is that I initially thought if it didn't say if, then it wouldn't be a conditional statement, but he said it doesn't have to be, and therefore it C's the answer. So
Yeah, we could rewrite this as a conditional. We could write this in the format if, and what would we say?
if all obtuse angles have measures between if all obtuse angles
So it would start off with if an angle is.
obtuse, then the measures are between 90 and 180 degrees.
Yeah. Then the measure is between 90 and 180. Okay, so that would be the statement. But then if we want to get the converse of that statement, what would it be?
If if a measure is between 90 and 180 degrees, then the angle is obtuse.
Right. So the hypothesis of that statement would be,
The first part.
yeah, just this part. Good point. Does that all make sense now?
Yeah. I just thought I had to say if and then, but I know it doesn't now.
Understood. Okay, it looks like this is where he actually wanted the picture. But yeah, I would say you could contest the one that had the picture here, because this picture probably threw you off. Am I right?
Yes.
Okay. So
Yeah, but I got the wrong answer anyway, so I said transitive, so whatever.
yeah. All right, let's take a look.
It's a vertical. I think it's vertical angle theorem, and I don't know how I got that wrong. It's not substitution. It's not reflexive. And if it's definition of congruency, I don't see how that really makes any sense. So I would think it's. I would think it's the vertical angles because they are vertical angles and they are congruent with each other.
Okay, well, let's write down what the vertical angle theorem would be. The
Oh.
vertical angle theorem, if you were to write it down as a conditional, would be if two angles are vertical, then they are congruent. But that's not what this is saying. What this is saying, if we want to rewrite this in a sentence form, is it saying if the measures of angle 1 and angle 4 are equal, then the angles are congruent.
Okay, so that's the congruency definition then, right?
Yes.
So it's just the model that threw me off again.